Okay, let's see what is a decorator. So, a decorator is a function that can be used more times by other functions, and simply adding this thing here, a decorator here, this at symbol, and the name of the decorator that is printed before a function that want to use this piece of code here. And you see this piece of code that is used again by these two functions here are is into an inner function, as you see here. This is the function, the decorator printed, and this is the inner function that is inside of the decorator. So you see that the decorator has an argument that is this fn things that I put here, and um, this one is the function that calls the decorator. So this function here, when it's called, putting this thing here, um, is the add function. And when you call this function, this like in here that you call the subtraction function here, this function goes into here as an argument because there is this thing up here. So let's see what happens when I call these two functions, the add function and the print function. So these two function does some very simple basic stuff. Let me delete this thing here and let me just leave these two function with the most basic thing they can do, that is to return the sum of the two arguments or the subtraction of the two elements that you pass to this function. So the first one will add 5 plus 4, returning 9, and the second one will return 5 minus 4, that is 1. So this should return 9 and this will return 1. Okay, so what's the benefit of having this decorator here? You should write this thing 2 times for these two function and adapt it to somehow to these two function. If we don't have this decorator, of course, this is very simple as a decorator, but it can be very more complex. So you won't have to write this thing for each function, and you could have 3, 4, 5, how many different function here that uses some code in common practically. So what happens here is that when we call add, let's run this function. You see here, when we run this function, this doesn't just returns a plus b, because if I do hide the decorators, let's see what happens. Nothing, because you obtain something, but you should also do print this and print and print this to obtain something. Okay, 9 and 1, that is the result. But if you use the decorator, see what happens. You don't just print this name. So if you don't use the decorators, you won't have nothing. If you use the decorators, let me just show one, only for the subtraction. You see subt 5 and 4 is equal to 1, because here what happens, that it's like we call add before we return this value. This function goes in here, and the two arguments 5 and 4 goes in here. So here we have the function as global value, and here the result a and b as local value in here. So we have print fn name. The function name of this is subbed, and so it will print the function name here, subt, when you call this. But when you call the other one, if you use decorator also for this, you see that this one changes to add, because I first call add, and this will print the function name add. Then a and b, that is 5 and 4. Yeah, I can also change these values so to see that this will be different. Okay, in this case the result is -1. So we have add 5 and 4 because it's what I've written here, and is equal to fn. Here I can just use the function in here, and I will not have a recursion, because, for example, if I want to use it in here, printing fn name a and b is equal to fn, first of all, we don't have fn here. I should use add and add, but I can do it because it will give me an error, because it will go into a recursion, and in fact it stuck my Sublime text editor because it's calling itself for in an infinite loop. So you see, I should use other. I could not make it like this. I could go and do a plus b, okay, and so I had, but here now I don't show add, but I show show results. So it's not as good as this one. Instead, if I do so, it's all right. Add 5 and 4 is equal to 9. So I use the function here, this passed here. When I call the other one, I get subt to 3 because now fn is this one, subt. So and I use it here, fn.dunder name, where is contained the name of the function itself, and ab, that are the arguments of this one, so 2 and 3, is equal to -1, because here is equal to function. In this time the function is subt ab, so it will do 2 minus 3, that is equal 1. So we have written for the two function here, we don't have to rewrite the same stuff. So let's make for another example with a multiplicator here, a and b, that returns a multiplicated b. If I go mult 2, 4, 5, should be 10. Okay, it writes nothing. It writes nothing. I should do print mult 2 and 5 to have 10. But if I use the decorator onto this one, let's see what happens. Mult 2, 5 is equal to 10. So you see that now I've added this line of code here, so that it not only returns me the result of mult 2 and 5, but it also print this well-written line. It's like this was part of this, because you see here I've just made mult 2 and 5. If there is no decorator, this will not make anything except print 10 here in the interpreter. Instead, it says mult is equal to 10. So that is basically how a decorator works. It's in the most simple way you can use it, and you can so reuse um, some code for different functions that maybe like this one are similar, so that you don't have to use this line of code for each of this one. And I can go and do my code more readable, and I can make a division like this. See what happens if I divide 2 for 5 it's 0. If I divide 10 for 5 it's 2. And that's all. Thank you. See you next time.